Hi everyone, I'm Prithvi Prasekaram, IT 223-58820. Me and my team discuss about the vulnerabilities which we found in existing application. And our group ID is 43. So I will explain the first vulnerability which I found. So first one is SQL injection. So we run our existing project and find some vulnerabilities. Based on that, my one is SQL injection. So let's see the code. So the previously our React frontend built API request for the monthly report by concatenating query parameters directly into the URL like this. So to sorting out this issue, the back and also the backend then use the raw values in database queries. This could be an attacker to inject malicious SQL. For example, drop table users like that. The results could be bypass authentication by data theft and even deletions of records. So this is classified as CWA 89 SQL injection. So with the critical CVSS score is 9.1. To fix this, I implement the front end, like replace the manual concatenation with this get method like this, and on the backend here I use the sanitization with the parameters queries, and also for the backend um, you can say for the backend, we implemented strict server-side validation and whitelisting. Only integers allow for month like 0 to 11 and year 5 years, and invalid inputs default to current month and years. And Mongo's queries use typed data date object ensuring parameterized executions and generate error like generic uh, error messages to prevent leaking database information like this. So from this, the SQL injection entry points are eliminated and risk level reduced from critical to, this is a critical one vulnerability. So reduced from critical to low, and even if front-end validation is bypassed, the server enforces safe input and parameterized queries. So by combining safe front-end encoding and server-side validation and parameterized database queries, the application is now robust against SQL injection attack. After finishing my fixed my implementation, I ran the code in Slab, and finally I didn't get any SQL injection vulnerability here. Then the next one is weak password policy. Initially, our system allowed to user to register with extremely short password like 1 or 3 characters, even a little less, so 1 or 2 characters, and there were no rules to enforce complicity. This made the application highly vulnerable to brute force attacks, credential stuffing, and dictionary attacks. So because attackers could easily guess the weak password, right? So the risk level of the vulnerability is consideration high. So because it directly impact confidentiality and integrity, an attacker who gain access to an account could view sensitive information or even modify our user data. So now to correct this issue, I implemented a strong password policy. Now password must be at least 8 characters, and also the uppercase and lowercase and number special characters. And I applied validation both front end and back end. First of all, let's say like with I will register with 3 characters. It will say 8 characters needed, and I type some characters only. Then it says passwords must be 8 characters also with uppercase and lowercase and number, and also the special characters. So for that, uh, yeah, here the passwords must be characters and the things, and we put up input validations here. So I applied validation both front end to guide the user, the most importantly on backend to ensure that rule cannot be bypassed to the direct API request. So you can see that this code. By enforcing these rules, the system is now aligned with security best practices, such as those recommended by OWASP. These corrections should increase our application's security. Thank you. Titus will continue.
Hi, I'm Malindi. So I'll demonstrate the vulnerabilities and the exact fix I implemented. So SAP reported a time-based SQL injection style payload against this complete endpoint. So although our service uses MongoDB, that prop could be exploited if we accept unvalidated IDs or untrusted values. So it will causing slow or unexpected DB behavior and enabling injections like attacks. So here I replaced the unsafe handler with a single robust toggle complete implementation that validates the ID early where Mongoose is valid object ID, whitelist body input, only unit price accepted, and passes it with number, uh, rejecting non-finite and out of range values, perform all business logic in server side, and sanitize output using XSS. Here, if I try to complete a task, it will ask a unit price. If I give like random number like this, like invalid unit price, it will give 400 bad requests. Previously, before I fix this, I got 200 success. Next, I'll demo the persistent XSS finding and the fix I applied. A scanner found stored XSS. Attacker supplied string were stored in the DB and returned in JSON. If a front-end uses in HTML to render these values, scripts would execute. Even though the response is JSON, client code could create an XSS sync. So for that, I implemented server-side sanitization using the vetted XSS library, and I sanitize income string fields before persisting, and again sanitizing output fields where before returning JSON. Additionally, I added schema constraints, trim, and max length to limit payload size. Thank you.
So for my contribution, I focused on fixing an application disclosure vulnerability and implementing Google OAuth 2.0 with OpenID Connect. Okay, so first of all, let's have a look at how I did the login with the Google OAuth and OpenID Connect. So when I click on this continue with Google, it should come to this page where you should be able to select an account and continue with it. So after authentication, the Google returns an authorization code which backend exchanges for an ID token. The ID token is verified and we issue a session JWT for the user. So this improves security by removing the need to store passwords, dedicating identity verification to Google. So this improves security by removing the need to store passwords and dedicating identity verification to Google following the OpenID Connect standards. So application disclosure happens when the system accidentally reveals internal error details like database errors, stack traces, or server info directly to the user. For example, before fixing the database connection failed, the response showed the exact MongoDB error message with host and port. An attacker could use that information to plan more targeted attacks. So as you can see in my Zap report, we have the application error over here. So these are the kind of URLs that got affected by this vulnerability. Um, how I fix this is by updating the code so that errors are only logged on the server using console.error. While the client only sees generic messages such as like bad request, um, internal server error, item not found. Um, this way, the sensitive technical details are hidden from the end user. So why it's so important? Prevents attackers from learning about the system's internal structure, database engine, or configuration. By sanitizing error messages, we reduce the risk of targeted exploits and make the application safer. So this is a Zap report after my fix, and as you can see, the application disclosure is not here, so we have fixed it. Summary. I fixed the application disclosure vulnerability and implemented the secure Google OAuth OpenID Connect login flow as my contribution. Thank you.